section 4.3, page 11. On this page, we are given the graph of f of x, and we want to sketch a graph of f prime and f double prime. So things are a little bit different here. Sometimes you have to think about and say over and over in your head, what graph am I given and what graph do we want to draw? So this is the graph of f of x. And we notice this chart down here. We are going to have to fill in the chart. And do you notice this piece over here is missing? There's a description column over here missing because we don't need to describe f of x. We have f of x. We are interested in what f prime and what f double prime are doing. So the first thing that we're going to do is we're still going to look for relative max, relative min, okay, so on this graph of f of x, there is a relative maximum at x equals 0. There is a relative minimum when x equals -2. I also want you to find points of inflection. And points of inflection, again, where this graph of f of x is changing from concave up to concave down, or vice versa. And I see this is definitely being concave up, and this is definitely being concave down. So changing right here at x equals -1. Other things that you want to look for, they don't show up in this graph, but other things that you should look for is horizontal tangents that are not extrema. So not a maximum, not a minimum. You also want to look for vertical tangents and cusps. In this case, or in this graph, none of these things are showing up. We only have information going on at 0, -2, and -1. If we set up this table over here now with that information, okay, now when we want to find f prime from an f of x graph, then we need to read slopes of tangents. And when x is less than -2, the slopes are negative. When x equals -2, we hit a 0 slope on f of x. When x is between -2 and -1, positive slopes. At -1, be careful, the slope here is positive, not 0. From -1 to 0, slopes are positive. At x equals 0, slope is 0. And after 0, slopes are negative. All right, let's take that much and let's sketch a graph of f prime. And what do we have? At -2, f prime is 0. At 0, f prime is 0. To the left of -2, f prime is negative, something underneath the x-axis. In between -2 and 0, f prime is positive. And when x is greater than 0, f prime is negative. That's it. Don't make it any harder than it is. That's all. All right, let's look at f double prime now. F double prime, reading that from an f of x graph, you are going to read concavity. And this graph of f of x is concave up all the way until x hits -1. So positive, 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 oops, at -1, 0, that was one of our points of inflection. And then after x is -1, f of x is concave down, so f double prime is negative. When we sketch this graph, we know that x equals -1. There's a 0 on f double prime. To the left side of x is -1. F double prime is positive. And to the right side of -1, f double prime is negative. Ooh, let me raise that up. I'm sure you didn't see me draw that. I'm so sorry. F double prime is positive when x is to the left side of -1. F double prime is negative when x is to the right side of -1. Just one more real quick thing in connecting these three. Doesn't this graph of f of x look like a cubic function? And then the derivative of a cubic is quadratic, and the derivative of a quadratic is linear. Isn't that cool the way that all connects together? Have a nice afternoon. Thank you.